Hello, everyone. Thank you for joining us today, whether you're listening to us on Spotify or watching us on YouTube. It's great to have you with us today. I'm Twain Taylor, editor at amazic.com. That's amazic.com. And I want to encourage you, if you like what you hear on this episode, go and check out all of the other episodes we've been doing on similar topics with many leaders and influencers in the cloud native space. I have with me today Neil Cresswell, who is the CEO and co-founder of Portainer. And we're going to be talking about managed Kubernetes and what Portainer is doing in this space. Neil, it's great to have you with us. Thanks for joining. How are you doing?
I'm very good, thank you. And thanks for having me here.
All right. If you could get us started telling us a bit about your journey up to co-founding Portainer, we'd love to hear that.
Sure, my background is one of an engineering um, discipline. I started out in IBM, started out fixing hardware, became a storage and virtualization engineer, became a VMware specialist, spent many years inside data centers, designing, building, troubleshooting VMware solutions. Uh, Bit of a networking guy. I like to call myself a kind of Swiss Army knife of IT infrastructure.
Mhm.
Spent time as a CIO, spent time running a public cloud provider as a CEO. So had experience uh, both as a consultant and running companies that sell IT solutions into the market. And my entry into Portainer was about 6 years ago, I think 6.5 years ago, when I was actually running a public cloud provider up in Asia, and I wanted to deliver containers as a service as an offering. And at that time, it was very new technology. I needed some kind of management portal or some easy way to help people consume containers as a service. At the time, something like Amazon ECS was very, very new. And so I was trying to deliver a relatively similar experience to that. And so, yeah, Portainer was born of that elk. It was like, how can I create a cloud provider portal that makes it easy to use? And yeah, Portainer's kind of retained a lot of that core DNA. Yeah, it really is a way of delivering your own container as a service platform using whatever infrastructure, whatever Kubernetes distro, Docker, anywhere that you like. So it's kind of retained a lot of that core DNA from the early days right through to now.
Mhm. Wow, really cool. Yeah, sounds like you've seen quite a bit of the cloud evolution from hardware servers to virtualization to containers and Docker and Kubernetes and all of that, right? It's been quite a journey.
Yeah, I like to think that it's given me a lot of very useful background. When you run a cloud provider, you realize very, very quickly that it's very, very difficult to avoid outages. In fact, I would argue almost impossible to avoid outages. And so it becomes critically important to have a very good plan in place for how to deal with outages when they occur, because they will occur. So how do you manage them, and how do you ensure that you have the greatest number of people in your company able to support your platform? So in times of emergency, you can get 20, 30, 40, 50 people, however many people you have, helping you to troubleshoot. Relying on just one person who knows how this particular piece of the infrastructure hangs together is very, very dangerous. And when I was a CIO, I learned very quickly that developers and I was a CIO of a company that was a big e-commerce provider. And I learned pretty quickly that these developers were spending so much time managing the e-commerce infrastructure and not creating new innovations in the e-commerce marketplace and system, that I was beginning to lose competitive advantage because they were too busy in the system. And so I learned again very quickly, you want to keep developers focused on activities that drive value for the business, and try and remove as much complexity out of the infrastructure that the developer has to use. And a lot of the stuff, again, this all helps me in this Portainer journey, because when you think about containers, the whole premise behind containers is actually a thing called shift left, and it's actually shifting a lot of the tasks related to deploying and managing the infrastructure that underpins an application to a developer, and a lot of that is now wasting developers' time when they could be doing far more business value add things. So, again, there's so much DNA intertwined there in Portainer. How do I remove complexity from the infrastructure? How do I make it easier for developers to consume a container service and remain efficient? All the stuff is interwoven. So if you look at my career, it's basically fundamentally imprinted in Portainer.
Neat. Interesting that you brought up the idea of shift left. And I was wondering what your take is on that, because on one side, there's this idea that shift left means developers need to be involved with all the other aspects of software delivery, including security and reliability and all of that. And then there's this other concept of where, they're still, trying to bring the separation between the developer and the platform team, and just saying that, let the platform team manage the infrastructure. And so the developer gets to just deploy the code they write without worrying about how that infrastructure is provisioned. So that these two kind of seemingly at odds with each other, these two ideas. How do you look at that, especially since you commented about shift left? How do you look at this idea of the role of the developer and the rest of the team that's involved with software delivery?
So it's actually quite an interesting one, right? And if you think back a few years, there was this amazing concept called a shadow cloud, right? And shadow cloud existed because the business, and the business entails a bunch of different roles, including developers, wanted to innovate and create really cool new points of difference for the company, be that big data, or at the time it was ML because there was no AI, and wanted to innovate with things like Shopify and all these other cool SaaS services. And the business wanted to ask IT for this capability. IT had no ability to deliver this, either didn't want to or had no capability to, and so became the Department of No. That's how they were known. So the business said, well, we still need to innovate and create cool new products, digital products and services for the business. So we're just going to do it around IT. And to be fair, I think that's where shift left came, right? Because now the developers have said, well, I'm going to do it myself, and put on their cape and off they go. And so at the time, they found a way around IT. Now, over time, that's been accepted as, hey man, at IT we were wrong here. Our job is to actually enable our internal users to be efficient. And so we have to empower them with self-service tooling and capability to do what they need to do to deliver cool business services and not get in the way. And so hence why you see things like IDPs now, the internal dev platforms, because they're trying to solve that same problem. But the problem with shift left is, if you're shifting highly complicated tasks left, the person you're shifting it onto needs to know what they're doing really, really well. We had people who were super specialists in network optimizations and storage performance tuning and security and all these things. We had specialists in the IT infrastructure world. We've shifted all this to dev, and all of a sudden we expect a dev to be a ninja of everything. We expect them to know how to do deep security and infrastructure management, and how do I ensure that my database has sufficient disk I/O performance, and how do I do this? And I'm not entirely sure that's giving us the right outcome, which is why I think there's a little bit of a swing back the other way that says, okay, now actually IT, you guys are the specialists over here. The platform team are the specialists. Let them publish a service catalog that the devs can consume from, that is optimized and efficient and monitored and governed and everything else. So we can empower the devs and the business to do cool stuff without getting in the way. Yet we have the tooling to ensure that they don't have to make decisions on things that they may not necessarily be skilled to make on.
Mm-hmm. Interesting. Yeah. I think that's quite true what you're saying, and how that there is anti-patterns that seem to be forming along the way that need to be addressed. And I want to bring in, we're talking about container management, and of course, the big idea around container management recently has been Kubernetes, and it's definitely made a big impact in the space, and pretty much everyone runs Kubernetes now. And I want to get your view on just managing Kubernetes day to day. What is the reality that you see as you speak to people out there who, who run and manage Kubernetes? What are the stories you hear? What are some of the challenges? Because being a container management solution, I'm sure that Kubernetes comes up in pretty much every conversation you have with your customers. Tell us a bit about Kubernetes and what you hear from your customers.
Yeah, I like to compare and contrast, and it just comes back to my background, right? So I like to compare and contrast a virtualized server estate where you had a hypervisor, a cluster management tool, observability or monitoring tools. You had a tool set that often 99% of the world was VMware powered. So you had a tool set that was designed to spin up and monitor and manage your virtual machines. Um, and we become very well accustomed to that tool set, right? And then we transitioned into containers, and there are so many similarities between virtual infrastructure and container infrastructure. I mean, VMs and containers are not the same, so don't make any mistake there. But there are similarities. You've got your container host, which is a bit like the hypervisor. You've got your orchestrator, which is a bit like the cluster manager, and then you need to have the management tooling. In VMware speak, the VMware vCenter of the world, the tools to monitor and manage. You still need these same tools. Nothing's changed in the world. You still need these kind of tools. And so a container management platform says, well, how do we take a raw Kubernetes cluster, which in effect would be like, so if you just say I'm running Kubernetes, that's like saying I'm running VMware ESX, and that's it. It's like no one does that. You always run a management suite of tools around it. And so a management platform says, how do I take a raw Kubernetes environment and overlay the tools and capabilities to turn this thing into an actual centrally managed and governed platform? And a lot of people, and I hear this all the time, and it really irks me. People say Kubernetes is easy. Well, it is if you have a very, very high starting degree of competence. I can't for 1 second sit here and say Kubernetes is easy for the entire IT world. It's simply not. And if you took a broad spectrum view of the IT, the IT business units or the IT departments across companies all across the world, there is such a massive difference in technical capability. You cannot possibly say that Kubernetes is easy for everyone across all IT departments in the world. It's just not the case. And anyone who says that is, I think, sitting in a very, very isolated view of the world. And so our whole view of Portainer is, well, how can we make it as easy as possible to manage a fully fledged Kubernetes platform like you would as if you were managing a virtualized platform? So how can you get multiple clusters? How can you have central control and governance of these? How do you ensure that you've got single sign-on user authentication of these clusters? How do you ensure that you have a single place that you're defining role-based access control? How can you centrally deploy security policies that govern all these clusters? How can you do this? And if you think back again, just go back a few years to a VMware estate, if you had 5, 10, 20 VMware clusters, there's no way that you're managing those one by one by one. You had a central tool that did that. It's the exact same thing. And we're not building rockets here, right? We're simply saying how do we create a piece of software that essentially manages all of these environments in a really simple to use way. That's kind of the ethos.
Mm-hmm. Yeah, I think it's absolutely true what you're saying, that I think it's quite easy to get started with Kubernetes, but then I think once you start running something at scale in production with all of the security and reliability needs, it quickly becomes really complex. And so, yeah, there's the day two ops and how that's difficult. Um, could you talk a bit about, a little bit more on just these challenges with Kubernetes, and sort of, if you could voice some of the pain points, some of the warning signs that maybe someone who's listening to this, they could probably say, hey, yeah, I relate to that. I understand that. I think I kind of go through this with Kubernetes, and I didn't think of it that it shouldn't be this way. What would you say are some of those warning signs that someone should pay attention to if they're struggling with Kubernetes and somehow just pushing through, but they need not be doing that?
Yeah, I mean, one of the big problems I think with Kubernetes is you don't know what you don't know, right? And Kubernetes is an absolute beast of a thing. It can do almost anything you can possibly imagine. It's so infinitely flexible, which is,
Mhm.
to be fair, what makes it awesome. But it's also what makes it incredibly complicated. Um, because you've got CRDs, your operators, you can train the cluster to do anything. It can be a really magical piece of technology. Um, but we seem, and again, if you read the surveys, we seem to be making a lot of the same simple mistakes over and over. Incorrectly secured clusters, incorrect RBAC configuration, not applying sufficient policies, not correctly backing up and managing the cluster, not understanding the cluster architecture. There's a bunch of things that I think we just get wrong because we don't know what we don't know. If you have to open up a kubectl command prompt and start doing something in the cluster, if you don't know the command, where do you begin? You can't just say, hey, I mean, yeah, ChatGPT is making it easy that you can start to get a bit more conversational and ask questions and get some kind of clues. But oh my goodness, if you don't know the command to type with dash dash help at the end of it, you kind of get a bit lost and it's quite complicated. So one of the things that we find is people configure Kubernetes just enough to do what they need to do and then stop. They don't actually fully configure it. So yeah, it's a very common and sad occurrence to see Kubernetes RBAC incorrectly used. It's a very sad and common occurrence to see the Kubernetes API just exposed to the raw internet with any real consideration. Very few people deploy things like OPA Gatekeeper because it's pretty complicated. OPA Gatekeeper is a admission controller to say don't allow my developers or my internal consumers to request applications be deployed in the cluster with certain dangerous characteristics. OPA Gatekeeper is a great way of putting a barrier fence up and saying, you can't do that. That's dangerous. But people don't do that because writing OPA Gatekeeper policies is hard. So they just don't do it. Same with RBAC, right? If you don't understand how Kubernetes RBAC works, you can very, very quickly have a misconfigured RBAC configuration, and you may not know this, but a user logs in and can now do something in the cluster that the person who created the RBAC role for them may not have intended them to do because of a lack of knowledge how Kubernetes RBAC propagation or hierarchy works. And again, just because you can do something doesn't mean you should. There's a whole bunch of infinite config options, making sure it's configured correctly. And so that's what we see is how can we make it really simple to configure OPA Gatekeeper policies with click, here's a list of policies, which ones do you want? Well, that one, go, and we do it for you. Okay, I want to let this user from this Active Directory group have access to these clusters, and in these clusters, these are their roles, and we take care of writing all of the RBAC policies to the cluster correctly configured. This is super important. If you can make it incredibly easy to correctly secure a cluster, more people will have clusters correctly secured. It's just simple logic.
Very interesting. And so we defined the problem well, and you kind of hinted on even the solution. But I want to get into that now, talking about just what Portainer does. And obviously, the managed Kubernetes space itself is quite crowded. You have the big cloud vendors with their managed services for Kubernetes, and then you have a whole range of options as well in the space, each taking different approaches. So considering this, how would you introduce Portainer to someone who's curious to know, hey, what makes Portainer different?
So one, we are not a Kubernetes distro. Okay, we don't ship our own distro. We're not even pure Kubernetes. If you want Kubernetes and Docker, we can do both. And a lot of people and companies start their journey with Docker because it's just easy. If you've had no exposure to containers before, and you're going from an application deployed on a virtual machine, a monolith to microservice, there's some learning to go through. You need to understand how service discovery works when you have an application that's spread across multiple containers. You need to understand how that containers are stateless, and generally are stateless, unlike a virtual machine. And you have to realize that whenever you do an update, it's going to destroy and recreate your container. So you need to ensure if you need state, you're storing state in a persistent location. So there's a whole bunch of stuff there. And so Portainer's job is to help you go from, I just want to get started with Docker on my laptop, on some servers in the data center, maybe to a Docker Swarm cluster. And everyone says Docker Swarm is dead. And yeah, it's being underdeveloped compared to Kubernetes. It's being outmarketed compared to Kubernetes. But my goodness, it's easy and it just works. And we still see a lot of people using it because it's easy and it just works. Same reason why Amazon ECS is still around. It's easy and it just works. So we see people go Docker Swarm, and Kubernetes. We've got customers who use all three at the same time in the one product, centrally managed and governed. So that's our difference. The other difference is we are not a SaaS offering. You run Portainer inside your own infrastructure. I am not a huge fan of handing the keys to the kingdom. And by that, I mean, root access to your entire infrastructure platform to a third party. If you think back again to VMware days, would you have given admin login to your VMware hypervisor to a third party? Probably not. So, I like the idea of having Portainer self-hosted as opposed to a SaaS service. And so we support any Kubernetes distribution from anybody. Docker Swarm, self-hosted are the three big differences, I would say, compared to others. We're a product you subscribe to and use, and you govern and control it yourself. So there are massive benefits to us not being a SaaS service. You upgrade Portainer at a time that suits you, not when it suits the SaaS provider, and you're not sharing your credentials with any SaaS provider. And I think the actual security risk of a SaaS service is often understated. If you look how many times very, very big cloud providers are compromised, if you look at security vendors, when are they got, like LastPass, an example, been compromised a few times. If the people whose specialization is security get compromised, those who don't specialize in that, are you sure? That's why I quite like this Portainer as a self-hosted solution.
Interesting. But then on the other side, how secure is it when you're self-hosting your container management platform, right? I mean, what do you see? I mean, because if at least one way of thinking of it is that if it's SaaS hosted, then the vendor takes more responsibility and kind of is working at it continuously to make sure everything is reliable and secure. But if it's self-hosted, then isn't it kind of different for each customer? Do you see that at all? Like each customer having different levels of security and maybe even reliability?
Not in our product. But we obviously we release version updates very often. We still manage ourselves as if we're SaaS. So we actually ship new versions often. And it's very easy inside Portainer to upgrade Portainer, as you'd imagine. So if you think about exposing your management controller to the internet, that's never a good idea. And so Portainer is often a tool that's consumed internally on your LAN or on your corporate VPN, so it's not exposed externally. We make it very easy for you to configure Portainer against your internal authentication source, be that Azure AD or LDAP or whatever else you've got, including multi-factor authentication, single sign-on. So Portainer can be tied to your authentication. So you're not maintaining a separate authentication source in Portainer, so it's quite secure in that regards. We make sure that Portainer is pen tested on a regular basis to make sure that our internal security is what we say it is. So I don't think it's any different. It's still a subscription piece of software that's updated on a regular basis. It's not like a piece of old perpetual software that you buy once, you never buy support for it, and so therefore you don't have any right to upgrade it. It's a subscription. You get a new update every 8 weeks or whenever we push an update to the software. So as long as you update on a regular basis, you're always kept constant. And whenever you switch from legacy infrastructure to more modern container-based infrastructure, you are buying into an open source core. Open source cores have a lot of CVEs because they're open. Everyone can see them, report on them, which means that you have to update far more often. I know some people who didn't update their VMware estate, except once a year. your Kubernetes or container platform, you should be updating once a quarter or however often there's new versions, because the CVE is being discovered all the time. So.
Yeah. And another thing that I was curious to know more about from what you said is just Docker Swarm, and even Docker. Is this something that you suggest to your customers that, hey, you're finding this really challenging with Kubernetes? Why don't you try Docker Swarm just for this part of your workflows or your infrastructure? And then they find it, a lot easier and better to do. Is that how it comes up, or you find that your customers themselves have already been using Docker Swarm and they come to you saying, because we've heard that Portainer also manages Docker Swarm alongside Kubernetes, and that's why we've come to you. What happens more often than not?
If all you have is a hammer, everything looks like a nail, right? And we like to give our customers freedom of choice. So Kubernetes, like it or not, has a degree of management overhead. That's just a fact. Someone needs to know how to troubleshoot etc or troubleshoot kubedns or troubleshoot the components if something goes wrong in the cluster. Docker Swarm has way fewer moving parts, way fewer. So if your company can't afford to recruit, retain, retrain someone to be a Kubernetes support engineer, then maybe your existing Linux engineers are able to do some relatively simple education and become competent in Docker and Docker Swarm. Maybe that's actually a better fit for your type of organization. Maybe this type of application that you're running actually would benefit from some of the features of Docker Swarm. Docker Swarm has a really cool networking topology called MAC VLAN, which is where a container can get a real IP address on the physical layer 2 network. No netting or routing involved. It's just a layer 2 bridge. That's quite cool. Maybe your application needs that particular piece of functionality. And so we have an entire tool chest in our product. So we have a hammer or a screwdriver or a drill. We have anything. And so the ability for us to help customers solve problems with the right tool is, I think, our key strength there. If Docker Swarm works better for you, go ahead. And we've had some customers who have struggled with Kubernetes, and we said, hey, have you seen Docker Swarm? It's still around. It actually might fit your job better, and they deploy it and they like it. But we also do see a large number of people coming to us who have said, we tried Kubernetes, it became an operational nightmare for us, and we wanted to simplify our lives. We wanted ECS, but we needed it self-hosted. Docker Swarm was the closest that we could see to that. And so we're seeing it from both directions.
Wow, really interesting. So yeah, the toolkit or the tool chest that you're talking about, we'd like to see what that's like. And if you could walk us through Portainer, the dashboard, and some of the key features, and show us visually, this is what it looks like in practice. I think that'll really crystallize all that we're talking about.
I can try that. So here I have a Portainer instance up and running. Again, Portainer is a centralized management tool set. So you deploy a copy of Portainer somewhere in your infrastructure. This one happens to run in the cloud, but that's irrelevant. So you just deploy Portainer on a server or on a cluster. I always like to say you run Portainer on a management server or a management cluster. You wouldn't normally run your management tools in the cluster that they're managing. So you have Portainer running somewhere, and then you plug in all of your infrastructure into Portainer. So you can either deploy new infrastructure out in the cloud or on-prem on your virtual machines from Portainer, or you can deploy them externally and then deploy our agent and plug them into Portainer, but you connect them to Portainer. Here is an example. I just have a Docker server, happens to be running Swarm, but doesn't matter, which is where I'm running Portainer. And then I've got 3 Kubernetes environments. I had a Chromebook configured previously for a demo, just so you can see here. This one is not working. The heartbeat is down because the Chromebook is currently unpacked or it's in a box in a cupboard somewhere. So we have this edge capability, which lets us actually manage devices that are connected sporadically. So when this thing is powered on and turned on, I can manage from here as well. So from this centralized view, you can see we're already, it's obvious, we're a multi-cluster manager. We're not just a tool that runs one cluster, so you can manage multiple. We actually test Portainer up to 5,000 clusters every release. So we actually have an entire QA platform that spins up 5,000 unique clusters to test it. So we know that we can already manage a relatively large number of environments from one place. And from here, you can do things like configuring your authentication. We do have an internal authentication mechanism, which is for non-production use. You can configure Portainer to authenticate against any of your OAuth sources that you need. You can do things like automatic provisioning and automatic team synchronization. So we can read groups from the upstream repository, look for users in groups, and put users in those groups into Portainer teams for authentication. From here, you can create all of your environments. So you can either like provision a new cloud cluster, and we've got these cloud providers that you can directly provision Kubernetes managed clusters from directly. You can create a cluster using on-prem virtual machines. Now, we have chosen to add support for micro K8s because, in my view, this is the closest you come to a KAS, a Kubernetes as a service offering. It's the closest you get to no-ops Kubernetes as possible. So we will let you build a canonical micro K8s cluster directly from within Portainer, and once you've got it there, you can manage it. Or you can actually deploy environments outside of Portainer and then choose any one of these options, and it'll give you instructions for how to install our agent to then centrally manage these inside Portainer. You see here we've got support for Nomad. We're actually taking that away. Nomad doesn't seem to be getting much of a pickup in regards to its orchestrator. It really is Kubernetes or Docker. Mm-hmm. And again, we don't really care where you run these environments. If you want to run Docker on your laptop, if you want to run Docker on a server in the data center at the edge, Portainer doesn't matter. We have, as you can see in the sidebar, we have a bunch of edge compute capability as well, which is, if you just change the word edge to fleet, for fleet management, it would probably give you a better view of what we're doing there. It's managing and deploying applications to groups of environments concurrently. So once you have your environments, you can put them into groups, or you can provide access directly to them here. And so you can say, hey, for this micro K8s cluster, I actually want to give a user a particular role, as I've already assigned the users here, but you can say, I want to give this user a role, and I can say, actually, I want to change this user's role from this role to this role and update it. And we will go and, we're changing the RBAC roles in the background for you concurrently. If you want to begin to manage an environment, you can say, hey, here is my micro K8s cluster. Here are the applications that are running in this thing. There's probably nothing running in this one, but here are the applications that are running in this particular cluster. I want to actually go and start to apply some productionization constraints on this cluster. So I want to do things like deploying OPA Gatekeeper. This is a bit slow now because I actually spun this up while I was in Europe. So this is actually connecting to an environment in Europe when I'm now back in New Zealand. But, so you can actually start to configure things like OPA Gatekeeper policies or whatever else here. And you can start to manage Kubernetes and everything from one central location. So it's really nice and easy to centrally manage and govern. You can see here we have these Kubernetes or these RBAC roles that we are predefining in Portainer to say, hey, look, this is what this is the type of mission that a user with this role has across the cluster. So some are cluster scoped, some are namespace or resource scoped. So you can start to manage everything in one place. But we like to be a bit of a GitOps engine as well. So you can choose to deploy applications inside the cluster, either with our form. So if you don't know how to write Kubernetes YAML, you can use our form to create yourself an application. Or if you actually want to have GitOps, you can say, I actually want to create from a manifest. Here is my Git repo, turn on GitOps updates, and we will now go out and keep the application running in the cluster in line with what's defined in the Kubernetes repo. Again, Portainer is trying to be the one tool you need. You don't need to go and deploy any other GitOps engine. You don't need you don't need an Argo or a Flux. You don't for OPA Gatekeeper. You don't need a Strya, I think they're pronounced. You can do everything in one place in Portainer. We're trying to just be the one tool you need to fully configure and run your platform. So, and by the way, a lot of people say, hey, this no code deployment of applications, the ability to add with a form is a terrible idea. And sure, in production, that's probably not a good idea. And so we actually give you the ability to turn off and hide the ability to use no code deployment for select clusters. So an admin can say, for this cluster, we want the devs to be able to experiment, and we don't want them having to worry about writing manifests, so they can use the form. For these clusters, actually we really want to be GitOps only, and so we're going to disable the ability to use any kind of no code mechanisms. And so these buttons are either visible or not visible based on what the admin says.
Really cool. Wow. It looks really quite configurable to where you can make it as clutter-free as you want, and you can add as many of these options and manage as you're talking about 5,000 clusters. That's quite some scale. So it seems like it's really configurable, and I find it's quite elegantly built. So congrats, great job with this. Looks really cool.
Thanks. The whole thing's actually, the back end is written in Golang, so it's actually super efficient. It'll blow your mind to think when you have Portainer that is sitting there managing 5,000 clusters, it needs about 8 gig of RAM and a single SSD hard drive to actually be able to essentially manage those 5,000 clusters. It's actually super efficient. Like this instance sitting here is probably using maybe about 100 megabytes of RAM and 0.1 of a CPU to sit here, this management instance. It's incredibly lightweight. So from that perspective, the footprint of Portainer is minuscule, and Portainer itself ships as a container. So you can actually get Portainer up and running in no time at all, either a simple Docker run command or a Helm chart, if you want to use Kubernetes, and you've got Portainer running. It's very simple.
Neat, neat. And I was curious to know about Edge and what you do. What led you to focus more on Edge? It seems like you're quite a focus on edge computing. So how did that happen? What do you do? Could you tell us a bit more about your Edge story?
Yeah, I mean, we started out life in the data center. That was kind of our bread and butter. We're a data center product helping people deploy business applications inside internal IT infrastructure. But one of the things we found is, we're really focused on making Portainer intuitive and really easy to understand, right? And there was a natural attraction of that out in the Industry 4, so the IIoT space, where you have industrial engineers, controls engineers, automation engineers who wanted to deploy Industry 4 software. And if you're not familiar with Industry 4, it's a very cool way of modernizing your factories, your oil and gas fields, your deep mines, whatever else. It's a way of having software to give you better management and control and monitoring. All of the software that powers in the Industry 4 transformation ships as containers. Now, containers is a very IT tool. Automation engineers, controls engineers out in industry are not IT people. And so there's this huge gap between a very, very IT-centric tool and non-IT people, and how do you merge the two together? And Portainer, it's fair to say, accidentally became quite attractive to that field. And so 2 years ago, we're like, well, hang on a second, we're starting to see quite a bit of adoption and growth in this industrial space. Maybe we should actually give a bit more focus and attention to this. And so we actually hired someone to help us steer or govern Portainer's product direction, to say how do we actually target capability in the product that better suits this type of use case. And so our edge compute features were born here. And what this says is you need to be able to centrally manage thousands of devices from one central location. You need to be able to deploy an application to all of these environments. You need to you'll have a common application deployed 1,000 times to 1,000 little micro devices out in the field, but each device is subtly different. And so how can you actually push a configuration to 1,000 devices that defines what this device is, and then have a generic application combined with a configuration that means this device is now running the version of the application for it. How do you onboard devices once they're onboarded? How do you update them? How do you ensure that the Portainer agent is auto updating to over-the-air updates? And so the edge compute features are all about mass or fleet management of thousands of devices in the field that are sporadically connected over high latency, low reliability networks, potentially connected on carrier grade NATs or 2G, 3G, 4G cellular connections. How can we manage them centrally in a safe and secure way? And that's really the edge compute features, is how do we do that? Designed for industrial IoT. It's used in automotive, it's used in oil and gas, it's used in healthcare or medtech. The use cases for edge compute are massive and accelerating rapidly. And it's all on the IoT bandwagon, so it's X IoT. Primary use cases, industrial IoT.
Mhm. Wow, really interesting that that was an accidental find, and also yeah, quite interesting that you're talking about the high latency, low reliability scenarios with edge, because oftentimes you hear the opposite where you need uh, low latency applications and use cases for edge. But yeah, it's interesting to see that you're solving for even this side of edge, and that's really cool.
Well,
Uh,
so there, let me be clear. People are putting devices out in the field because their application needs very, very low latency, real-time communication between the device and the piece of hardware or sensor in the field. So it's out there at the remote location to give nanosecond or microsecond response times, but between that device and the central data center, then you're over satellite, radio, low RA or low RAN network connections. That backhaul is high latency sporadic connection. So and you still need to manage them and over that connection. So that's what we're trying to do. And Docker as a technology, Kubernetes especially, it really is designed for the data center, and so it's a very synchronous API, to manage it. And so, how do you manage a synchronous API when you have a network that's quite unreliable? And so that's what we've done is command queuing and finding a way to actually deliver a command and control instructions to a remote Docker environment or remote Kubernetes environment in a safe way over a very unreliable network.
all right, great. So how would you recommend someone who's listening to this and is interested in Portainer, how do you recommend they get started?
So we have a really good resource online, academy.portainer.io. And this is where we are trying to teach you how best to get started with Portainer. So on that page, there is information about the reference architectures. So we have collated a bunch of reference architectures from how our customers are using us out in the field, data center, edge, you name it. So, and we describe the internal workings of Portainer, so you can really get a good understanding of how we work, all the agents, the authentication, RBAC, everything. And then there are a bunch of like micro courses that you can run through. It's like our 12-step plan, which takes you from nothing to a production ready Portainer instance. So you can just follow along the guides, and it shows you what Portainer is capable of in a really quick way. Otherwise, we produce a lot of YouTube videos that show how to use capabilities. So there's some great videos you can watch. We've got a really good one on micro-K8s, which shows how you go from nothing to a full production-ready micro-K8s cluster in about 9 minutes. I actually recorded a training course, Kubernetes the easy way, and we show you how to go from absolutely zip to a central Portainer instance, a cloud provider CAS, a micro K8s on premises, OPA gatekeeper configured on both clusters, centralized authentication against GitHub, so user authentication across them, and a GitOps pipeline deployed to both clusters. And that training course is about an hour long. And so it takes you from nothing to your application running at the tail end of a GitOps pipeline with a fully configured secured cluster in an hour. That is pretty easy.
All right, all right. Wow, lots of resources then. So definitely check out the Academy if you're interested to know more. So as we wind down, last question for you, Neil, is What do you find is the first impressions or the first results that your customers see once they switch to Portainer? What's the main differences they see? What do they say in their own words? What do you hear?
Portainer helped me discover a bunch of capability that I never knew existed. Is something we hear all the time. Again, if you're in front of a kubectl window or even a Docker CLI window, if you don't know the commands to type, you don't necessarily know the power of the platform that you are now commanding. Inside Portainer, we make it very easy for you to click around a UI and explore and discover things. And you're like, oh, what does this button do? Oh, wow, I didn't know I could do that. And then you'll go and read Academy or read our docs, docs.portainer.io. You'll go and read how this feature works and what it's doing under the covers. And you're like, oh man, that was pretty cool. And then you might go and research the particular piece of Kubernetes or Docker functionality that we're orchestrating with that particular UI element. So, the ability to discover the platform's capability is way simplified through Portainer. The other common thing is Portainer lets me do superhuman tasks. So we have a bunch of people who are doing things in Portainer against Kubernetes, deploying applications and doing things that they have no way of being able to do if they weren't using Portainer. If I took Portainer away from them and said, okay, cool, no problem, you've now got the Helm command line tool or the kubectl library or some other client-side library, these people don't have any real depth of understanding of Kubernetes, and yet with Portainer, you don't need that. We make it really easy. So, Portainer lets me do superhuman things.
Could you give us one example of one of those superhuman things that is possible?
RBAC as an example,
Mhm.
the ability to have a very, very complicated, multi-component application. What we call in Portainer is stacks. You can actually have a full, what would be a multi-line manifest where you've got your backend database, maybe a piece of middleware, a mem cache layer, a front end, an API gateway. You can have this entire stack of applications you can group together in Portainer, and you can deploy and configure all those things without needing to know how to write a YAML file. Portainer will help you deploy that application. We'll then give you the actual resultant YAML at the end, but you can actually go and deploy, build out and deploy a really, really complicated, multi-component, like a full 12-factor application with Portainer without needing to write a single line of YAML. We'll do that for you. And it's like, well, that's pretty cool. So you can have a stateful database over here or a stateful application here. You might have a stateless that's got horizontal pod autoscaler enabled over here. You might have an ingress controller, and you have all these things. And it's like, man, if you don't know how to write that in a manifest, you just couldn't even get started. And yet in Portainer, you can click your way to get that deployed. Again, in production, you wouldn't do that, but it's a really nice way for the devs to experiment and learn and learn how to build YAML files and how they work, experiment with them, get the resultant YAML, and then put that into a Git and have GitOps in production. But again, we just make it so easy.
Wow, that's really cool to hear. So, everyone who's listening to and watching this, hope you're excited about Portainer and just how Neil has described what it does and how it fits into the market right now. So go and check out the Academy and see what Portainer is capable of. And from the sounds of it, it sounds like Portainer really simplifies container management, whether that's through Kubernetes or through Docker, Swarm. And it's quite interesting, the approach that Portainer is taking. So before you go, Neil, we've got a couple of questions to get to know you a bit more. Yeah, yeah, this is probably my favorite part of the podcast. So first one for you is, which I ask all of the guests for sure, is what would be your alternate career path if not for your job in tech?
I have always wanted to be a chef. I made a decision when I was quite young to go into either IT or to be a chef. So yeah, IT was my hobby that turned into my job. Cooking could have also is a hobby that could have been a job. I still like to do that now. So any opportunity, you'll see me in the kitchen cooking up a storm.
Uh,
Could I
what,
deal with the pressure of a kitchen? Probably not. Of an actual commercial kitchen, but it's always this fantasy of being a chef.
do you have a favorite chef?
No. I do like Gordon Ramsay, just because he's pretty opinionated and cooks an amazing variety of food. But um, yeah,
Mm. Neat, neat. The next question for you is, what's one hobby or interest that you picked up during the pandemic?
I I got back into hiking. I used to be a Boy Scout when I was younger and used to go out hiking and camping, tramping and all that kind of stuff. And obviously, as I started adulting, my ability to do that diminished quite quickly. And so I got back into hiking again, and realized actually, you know what, I really like being out in the wilds and exploring and just downtime, free time, just walking and hiking. So I've done some, obviously I live here in New Zealand. New Zealand is a country blessed with beautiful outdoor space and very few things that can hurt or kill you. And so we can do some amazing walks here.
Wow, amazing. What's one software tool or product that you think is uh, built really elegantly?
My current tool of choice is Miro. Um, Miro is I describe it as a mind mapping tool. My mind goes at a million miles an hour, and I like to be able to mind map ideas. And Miro is a way for me to get what's going on in my head on paper on screen in a way that makes it easy for me to articulate to my team, in the most efficient way possible. So I use Miro a lot to basically visualize some ideas, product ideas, strategy. It's just a mind mapping visualization tool. Basically an endless canvas, so you can just dump your ideas down. It's a brilliant tool.
How do you spell that? Is it Miro?
Yeah.
Okay, I'll check it out. Next question. I don't know if you might have answered this in the previous question, but then I want to ask, what's your favorite way of learning?
Doing. I am definitely I learn by experimenting. I like to read blogs, figure out, try and deeply understand the architecture of a technology. I when I had to learn Kubernetes, I basically took 6 weeks and just went into a quiet room and learnt the architecture. I didn't start by learning the command line. That was to me irrelevant. I wanted to learn the architecture. So I looked at all the software architecture of how all the Kubernetes components hang together. How does the API server work? How does Kubelet work? How does everything interact? And so I learned how the Kubernetes networking stack works. So how does this differ from Docker with NAT? How does this differ? I learned the architecture, and then once I learned the architecture, then I started to experiment with the technology just by playing. So I've got myself a home lab. I run Proxmox at home. I've got a whole bunch of virtual machines, and I
Wow.
just experiment. So even now, I have an entire lab of Kubernetes clusters, of Docker clusters. I've got many instances of Portainer. I've got a whole bunch of stuff there. I've got Git running at home. I've got a full GitOps pipeline. I think a home lab is the best possible way to learn. That for me anyway.
Oh, really cool. So you're probably one of those frequenters on the Reddit forums, Proxmox and the other ones.
100%. You'll see me in there lurking. I try to answer questions whenever I can. You'll find me on the or in the Portainer Slack channel, in the Portainer Reddit channels. I'm occasionally on Discord, but not often. And I'll answer questions if I know the answer. Um, but I also use it to learn myself too.
Yeah, yeah. Wow. All right, last question for you, Neil, is at a conference or a party, you're usually the person who is.
Believe it or not, I'm actually quite introverted. So normally I'm the person sitting in the corner,
Oh.
or sitting at a table talking to the people who are around me. I am not someone who will just randomly go up and walk up to people and start a conversation. That's very uncomfortable for me. I've had to learn how to control my introverted nature to do this kind of business and to do these kind of podcasts, other things. But I'm a very introverted person. So in a party, you'll normally find me in the corner.
Yeah, that's a surprise. And we got to hear from you here today. And what a pleasure it was. Thanks so much for joining us, Neil. I really enjoyed our conversation. And I hope our listeners as well enjoyed it as much as we did. So go and check out what Portainer is doing and check out the academy if you want to get started. And make sure to tune in again next week because we do these about once a week. So stay tuned and we'll see you on the next one. Thanks, Neil. Thanks to all of our listeners and viewers. See you then.
Thank
Bye bye.